Now we're going to hark back to the work on angles and apply it to bearings. Now the key things to remember about bearings is that you always measure clockwise from north, and you always give your angle as 3 figures. So if it's only a 2-figure number, you have to put a 0 on the front. So here's an example. We've got position A and position B, and we've got arrows pointing north from each of them. If you are asked to find the bearing of B from A, then start by thinking, which direction are we going in? We're going from A towards B, so put an arrow on the line to show that. Now you are standing at A, where you're going from, and you are facing north, and you need to turn clockwise until you're facing towards B. So what angle have you turned through there? This is a 55-degree angle. So the bearing of B from A is 0.55 degrees. Remember, it's got to be 3 digits. You can have something after the decimal point as well, but normally we just use whole numbers of degrees. How about the bearing of A from B? Okay, we're going the other way now. So we flip the arrow. And remember, we're going clockwise from north. So it's not this angle here, it's this one, going all the way around, or almost all the way around. Now, this bit is angles on a straight line, and they add up to 180 degrees, of course. So how can we work out what this bit is? We've got a Z shape, and the 2 north lines are parallel. So what does that tell you about this angle? It's the same as this one because A to Z alternate angles are equal. So alternate angles, so this is also 55 degrees. So we've got 180 degrees here and 55 degrees here. They add up to 235. So the bearing of A from B is 235 degrees. So what's the difference between the bearing of B from A and the bearing of A from B? Can you see why? Take a moment to think about it. Yeah, the difference is 180 degrees, and that will always be the case because this angle and this angle are the same, and this straight line is the difference between them. So if your first bearing is less than 180 degrees, you add 180 to find the equivalent bearing going the other way. If your first one is more than 180 degrees, you can't add 180 because then you'd be over 360. So you take away 180. Some questions for you to have a go at then. Pause the video, work out your answers, and press play when you're ready to go through them. Answers then. For 1, it's 0.95 degrees. For 2, 0.83 degrees. And for 3, A is 225 degrees, and B, the distance is 7.1 kilometers. If you got them all right and you're happy with those, fine, you can finish the video here. If you'd like to see how those answers were worked out, keep watching and I'll go through them on the whiteboard. Right then, number 1. Okay, the bearing of B from A. We're going from A towards B, so let's put an arrow on first. So the angle that we're looking for is this one here. And what do we know about this angle and this one? Well, the 2 north lines are parallel. So what we've got here is 2 co-interior angles. And co-interior angles add up to 180 degrees. So co-interior angles sum to 180 degrees. So this angle here must be 180 minus 85, which is 95 degrees. So the bearing of B from A must be 0.95 degrees. This one's a bit trickier, but we're going to use the same thing again. So the bearing of D from C, we're going from C towards D. So there's our arrow. This is the angle that we're looking for. Again, we can use co-interior angles here. So 72 plus this angle here must add up to 180. So that must be 180 minus 72, which is 108 degrees. Now we could work out this angle and then use co-interior angles, the same as we did there and here. Or we can say this total angle here is the bearing of C from D. And that is going to be the 108 plus the 155, which gives 263 degrees. And the difference between the bearing of D from C and the bearing of C from D has to be 180. So the bearing of D from C must be 263 minus 180, which gives you 83 degrees. And of course, we need to put that 0 on the front. So there's your answer. Now for number 3, we're going from P and we're going 5 kilometers west, which is that direction, and 5 kilometers south, which is that direction. So we'll call our point P here, and we'll say we're going 5 west and then 5 south. So of course this must be a right angle, and this point here is where Q is. So there's our diagram. And if we want to work out the bearing of Q from P, that means we're at P and we're going towards Q. Let's put a north line in from P. Going clockwise from north, it's that angle there that we're looking at. Now we know that this is a right angle, and what we've got here is a right-angled isosceles triangle. So if this is 90 degrees, then these two must add up to 90, and if it's isosceles, they must both be the same, so that must be 45, and that must be 45 degrees. So if this is 90 and this is 45, then if we take those away from 360, what we get is 225 degrees, and that's your bearing. So that's part A. And for part B, we need to work out the distance from P to Q. So we're working out the length of this side of the triangle. So PQ squared is 5 squared plus 5 squared. It's the hypotenuse of a right-angled triangle, so we can use Pythagoras. So that's 25 plus 25, which is 50. So PQ must be the square root of 50, which is 7.07 or approximately 7.1 kilometers.